All right, welcome back. Welcome back. How y'all doing? It's good to be back, right? Well, let's get back into it. When last we left our intrepid adventure of learning, we were about to embark on Unit 2. Unit 2 was going to cover the subject of logic. We were going to go into inductive and deductive reasoning, and we were going to talk about conditional statements, and we were going to talk about logical reasoning and truth values, and then we were going to get into like algebraic proofs, which would then go into geometric proofs. But we've lost like a month and a half of instruction due to school closure. And while logic is certainly an important thinking skill, and I eventually want you to get that content eventually. Some of this, what we're going to be doing in terms of logic, we'll be using in geometry just kind of naturally, and unfortunately, it won't be taught it explicitly probably this year, but you'll get it kind of implicit, and your brain will still be trained in how to do this kind of logical thinking. Apologize for my background clock there. And so today we're just going to move ahead with Unit 3, which is where we're going to talk about parallel and perpendicular lines and cut by a transversal and all that fun stuff. So get ready for my my video magic that's about to happen. Here goes. Okie dokie. So here we are. If I've done my job correctly, you should see Geometry 3, Unit 3, 3.1, Lesson 1, Lines and Angles. All right, and let's begin. The learning target today, I want you to be able to say that I can identify parallel, perpendicular, and skew lines. I can identify angles formed by two lines and a transversal. So put your name right in here where it asks, and hopefully you will put in learning targets here in your own words, or not just copy and paste, but at least I put this in here every time because I just want a little bit of evidence so I know you're actually taking a look at that learning target. You know, obviously, if you're hearing me, you've already heard it once, but this is the evidence that I've got. This is the way I know that at least you've looked at the learning target at the very beginning of the lesson and you just didn't scroll on by. Let's talk about the vocabulary here. Vocabulary. All right. Just to preload some vocabulary. Parallel. Parallel. When two things are parallel, they will never touch. Okay? So like this line here and this line here. Now, maybe it's not perfectly parallel because I'm just kind of sketching it. But do you see this relationship between these two lines here, these two line segments? These two line segments are roughly parallel because they have roughly the same slope. And if I were to extend them further on, hopefully they would never touch. If they were truly parallel, then they would never touch, no matter how far I extended them in either direction. And then kind of a little different from this is called perpendicular, right? If I got this line right here, and another line intersects it at exactly 90 degrees, then we call this perpendicular, right? If this angle here is 90 degrees, then we know that this angle here would have to be 90 degrees. Why? Because two angles that are on the same line, those two angles will have to, together they'll have to equal 180. Well, if this angle here is 90, what does this angle have to be added to 90 to be 180? Well, it'd have to be 90, right? It would have to be 90 degrees. Wait, and if that's true about these two angles, they have to equal 90 degrees when they're 180 degrees when they're added together. Then these two angles have to be 180 degrees when they're added together, which makes this angle here has to be 90. And wait, it happens again. If these two angles have to add up to be 180 because they're on the same line, which means this one would have to be 92 in order for these to be 180 together. So no matter what, these pairs always these two have to add up to 180. These two have to add up to 180. The only number that, if one of these angles is 90, you know that all of these angles are 90 suddenly, because you can keep bouncing back and forth, knowing that whenever you have two lines that intersect, that the two angles on either side of the line together have to add up to 180 because a straight line has a total angle measure of 180 degrees. All right, parallel planes. To understand parallel planes, you have to imagine, I'm just going to sketch it here. You have to imagine like a flat sheet of paper that goes infinitely in all directions, all right? Infinitely in all, my little tempted arrows here are infinite in all directions. And if I had another piece of paper that was over here and looked like dot, 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 kind of, you notice how it went dot, dot, dot here, right here? because I don't want to give the impression that these two things are like lying on top of each other. I'm trying to give the impression that this purple piece of paper is actually below or underneath the red sheet of paper. So the idea is that there's two sheets of paper, my hand represented a piece of paper, extending infinitely in two directions, and to be parallel planes, they have to be sheets of paper that never touch, just like the parallel lines never touch. And I can rotate them all sorts of ways, but the idea here is you have a plane, which is this two-dimensional figure that goes infinitely in all directions, and if they're parallel, they never touch. So parallel planes. Transversal, all right. This always shows up in every geometry regions. It's this idea of if there are two parallel lines, right? If there are two lines which I know to be parallel, if I know this line here is parallel with this line here, and there'll be like one of these that will give me this is the notation to say that they're parallel to each other. Then if these two lines are cut by a transversal, if they are cut by a transversal, which is another line that's going through them, all sorts of interesting things begin to occur. One thing that occurs is that, okay, so these two angles here, like we talked about, have to equal 180, which means these two angles here have to equal 180. And we already know from previous lesson that there's these things called vertical angles. Whatever this angle is here, angle 1, that's going to be the same as this angle here, angle 2, because these two angles are vertical. All right, so okay, we know that angle 1, and I'm going to call this angle 3 over here. There's angle 3. All right, these two have to equal 180 when I add them up. And then these two have to equal 180 when I add them up. And then angle 1 and angle 2 have to be the same measure. Well, I can actually know, because these are parallel lines, I actually know some other things. Like I know about corresponding angles. Angle 1 is kind of like in this upper right-hand corner of where this transversal, the blue line, intersects with the orange parallel, one of the orange lines that are parallel to the other orange line. I know, just because they're parallel, and I should have used the same color I used before. The color actually doesn't matter, but just to be consistent, that angle 4 here, I'm just going to call this angle 4. I know it's out of order, but that's okay. Angle 1 and angle 4 have to be also the same measure, just like angle 1 and angle 2 are the same measure, because they're corresponding angles. They're both in the upper right-hand corner of where this transversal, the blue line, intersects with one of the parallel orange lines. All right? I also know some interesting things like alternate interior angles. I know that angle 4 and angle 2 also have to be the same measure. And how do I know that? Well, one way I know that is because if angle 1 and 2 are the same measure, and angle 1 and 4 are the same measure, then that means whatever angle 2 is, that has to be the same measure as angle 4, right? Because they're both equal to the measure of angle 1. You kind of feel how that logic just jumped in there? If angle 1 and angle 2 are the same, and angle 1 and angle 4 are the same, then that means that angle 4 and angle 2 would also have to be the same, right? We can just give this, maybe it's easier to give it a number. If the measure of this angle was, say, 60 degrees, if angle 1 is 60, and angle 2 is the same as angle 1, then angle 2 has got to be 60. If angle 1 and angle 4 are the same, then if angle 1 is 60, then angle 4 is 60. And that means 2 and 4 are the same because they're both 60. Does that make sense now? With the numbers jumped in, kind of put in there? And we call this alternate interior angles. They're interior because they're inside where the two parallel lines are. They're inside the two parallel lines, and they're alternate. They're on opposite sides of the transversal. Alternate sides of the transversal. So that these are alternate interior angles, and whenever you have two parallel lines cut by a transversal, you have alternate interior angles which are formed, which are congruent to each other. Okay, and we have things called alternate exterior angles as well. Alternate exterior angles as well. I'm going to call this angle 5. All right. Angle 5 and angle 1 are alternate exterior angles. You kind of see why? They're alternate because they're on alternate sides of the transversal. They're on alternate sides of this blue line here, the transversal. They're exterior because they're exterior where the two parallel lines are. So just like these are interior, alternate interior angles, these angle 1 and angle 5 are alternate exterior angles. All right? Okay, I think that's good. I think that primes our vocab right now. Let's get started. Let's move on to this warm-up. I want you to try all the warm-ups on your own. So that means you have to pause this video and try these on your own. You're going to learn so much more if you actually struggle a little bit and try to remember all the vocab from previous lessons here. So give this a shot, even if it's hard. You know, get the wrong answer. It's fine. You can always correct your answer and edit it later. No problem with that. Just give it a shot because you'll learn more even if you make you learn more when you make mistakes. So I want to encourage you, make some mistakes, all right? Or get them all right, in which case, you know, you don't need to practice. But that's all right. This is pause me now. Okay? I'm waiting for you to pause me. Great, you paused me, and now I'm unpaused, and now we can go over this, right? You gave this a shot, right? Right? Okay. All right, warm up, match the term to the definition. Acute angle. All right, acute angle. Oh, ain't that a cute angle? An acute angle is an angle greater than 0 and less than 90. Do you see how this angle here is more than 0? It's got some angle measured to it, and it's less than 90. Let me show you where 90 would about be. I'm going to try to approximate with the red line where 90 would approximately have to be, okay? So this red line and this blue line here would be 90 degrees. They're perpendicular to each other. And if this blue line here is anything, if this blue line here was any, maybe I need this to do that? No, okay. I thought I could move my my blue line around. I guess apparently I can't. If this blue line here were anywhere in between this less than the red but greater than the blue, it would be an acute angle. So anywhere where I put this side of the angle where it's less than the red and greater than the blue, I create an acute angle. And right here, an angle that measures greater than 0 and less than 90 would be the correct multiple choice for this one right here. All right, let's move on. Match the term to the words, congruent angles, congruent angles. So congruent angles. Hopefully you remember that congruent means same size, same shape, equal in measure, all right? So we're looking for something that has same size, same length. Now, you might be tricked by this one because it's same length, but it's segments, and we're looking for angles. So we're looking for angles that have the same measure. There we go. Angles that have the same measure are congruent, all right? All right, same size, same shape, congruent, equal in measure, congruent. And I keep, whoop, there we go. Here I am, collinear. Collinear, remember what collinear means? Well, linear means line, and co means with. Just like your co-workers are people you work with. Collinear means with the same line. These 2 points here are 2 points that are on the same line. They are collinear. So points that lie on the same plane, that's coplanar. Nope. Points that lie on the same line, yep, that's collinear. Points that lie on the same line, collinear. Obtuse angle. Remember what an obtuse angle is? Well, hopefully you said it looks something like this. An obtuse angle is an angle greater than 90, and less than 180. Right? So I'm going to try to reproduce approximately what 90 would look like. Oops, sorry, that's a little household announcement going on in my house. Let's see. So this orange line segment would be perpendicular with this red side right here, this red line segment, and that'd be 90 degrees. And as you can see, this side is greater than 90, therefore it is obtuse. So we are looking for the multiple choice that gives us something greater than 90, less than 180. Yes, that's obtuse. Good. Do you feel good about these? You feel good about these? I'm hoping you're getting all these. I'm hoping. All right. Match the term to the definition, congruent segments. If 2 segments are congruent, then that means they have the same exact measure. And I'm going to try. I don't know if I did that right. I don't know. I don't know. But I do have tools in here, but I'm reticent to using them just because maybe I got it right or wrong. And hopefully you understand the concept here. All right. Let me measure this. Let me see if I got it right. I'm measuring this one at approximately, what do we want to call that? 8.8, 8.9. All right, let me try this one. Oh, that's pretty darn close. I'd say that's 8.8, 8.7, maybe 8, yeah. All right, these are pretty darn close to being congruent. So now you understand what the concept of that means. Wonderful. Make my ruler go away. Oh, no, ruler go away. Segments that have the same length. If two segments have the same length, they are congruent, okay? All right. So, here I am struggling to find when do we use parallel and perpendicular angles in real life? Certainly it's used in construction. The idea of 90 degrees in construction is used a lot. And so I found this silly example of here's this person here. He builds like giant constructions out of playing cards. This entire replicated building is made out of playing cards. And I don't think he glues them. I think these are just like stacked, okay? Which makes this really impressive. It means the whole thing could fall down if someone were just to give one piece of it a little kick. So his name is Brian Berg, and you can read about him. He's an Harvard-educated architect, and he kind of builds these little structures. So let's go review some of our vocab again. So parallel lines are coplanar. So if two lines are parallel, that means they have to be on the same plane, and they do not intersect. So we would read this. It says in the figure, line AB. So I see this little symbol here. It says line. I know that means line AB. The symbol here means parallel. Line AB is parallel to line EF. Okay, so let me find line AB. There's A, there's B. So line AB means this, means all of this. That's what is meant by line AB, right? And extending infinitely in two directions too. And then where's EF? There's EF right there. So there's EF. Trying to get it more exact. So they're saying that line AB is parallel. Line AB is parallel to line EF. These two are parallel, and that you see how they're on the same plane. Like if this little piece was a playing card, if it was a sheet of paper, then AB and EF would lie on the same sheet of paper. And why that's important is because there's going to be something called skew lines, which are not coplanar. Okay. Okay. So. Oh, they're going to give us more examples. Okay, perpendicular. Let's talk about perpendicular. Perpendicular lines intersect at 90-degree angles. So in the figure, line AB is perpendicular. This little upside down T means perpendicular to line AE. So I'm going to look for AB. I already knew that. That's right over here. And then line AE. Do you see AE here? All right. This line here is perpendicular to AB. And you see that little sign right there, right in the corner there? That means 90 degrees. 90 degrees. Even though it doesn't look 90 from our two-dimensional way of looking at things, we're looking at this kind of like a cube tilted, right? That change in the perspective that this is drawn in kind of distorts what this looks like. This looks to me two-dimensionally to be an obtuse angle, but that's because it's a 90-degree. It's trying to represent a 90-degree a three-dimensional figure tilted a little bit, but this is supposed to be 90 degrees. All right, skew lines are not coplanar. So line AB and EG. Where's EG? Let me find EG. There's EG. So EG goes up and down. AB goes side to side. They're not on the same plane. They will never touch, just like parallel lines will never touch, but they're definitely not parallel. They don't have the same slope. They're not on the same plane. So while AB and EG will never touch, they're not parallel because they're not on the same plane. So that's one thing you need, a requirement you need to know for parallel lines. They do need to be on the same plane. And then parallel planes. Do you see how if this was a playing card or sheet of paper, ABE, this plane here is parallel. It's parallel to plane CDG. So CDG is parallel to this little plane here. So this plane here, you kind of fill it in. It's parallel to this plane. All of this right here. These two planes are parallel. They are planes that will never touch. All right. So yeah, I'm trying to give this idea of a plane card, to give this idea to visualize planes. So identify each of the following. Oh, I could have made you do that, but it looks like I didn't. Let me show you. Give an example. Identify each of the following: a pair of parallel segments. So I have to find a pair of parallel segments. Let me see. Kn is going to be parallel to PS. Let me take a look at that. Kn, this line right here, Kn is parallel to PS. Where is PS? Yes. Kn is parallel to PS. They're on the same plane, and they will never touch. Do you kind of see that? A pair of skew lines. Someone's looking for a pair of skew lines, and one the example here is going to be LM and RS are skewed. So here's LM, here's RS. Where's RS? There we go. RS and LM are skew. They will never touch, but that's because they're not on the same plane. They are skew lines, or skew segments in this case. Let's see, a pair of perpendicular segments. A pair of perpendicular segments. MR is perpendicular to RS. So there is MR. Here's MR. Here is RS. And while it might not look like these are 90 degrees, they are 90 degrees in the perspective of this three-dimensional figure drawn on a two-dimensional sheet. These are 90 degrees. They intersect perpendicularly. I notice that, I can see that they are perpendicular because, do you see that little box there? That little tells me that these are perpendicular, that it's a 90-degree angle. And last but not least, a pair of parallel planes. So plane KPS will be parallel to plane LQR. So KPS, let me find KPS. Here's K, there's P, there's S. So all of this is one plane they're talking about. And then plane LQR, LQR, okay. And then all of this is the other plane they're talking about. So you see how these two plane cards are parallel planes? Good. All right. Give these next ones a shot. I don't know if I want to go over these. I want you to give these a shot. It's okay to get the wrong answer, but I think you've had enough front loading here to be able to at least make a legit attempt at these. So here I want you to find a pair of parallel segments. So just find a pair of parallel segments. Use the notation. So for instance, remember how I told you this notation here means that things are parallel, right? So that helps right there, right there. Just using the notation, you could know that this is parallel to that, right? And I won't say it because I want you. Actually, I will give you one example. I'll give you this one as an example. Here's what I want to see when you write this in. I want you to use the notation, like the geometric notation. Since actually you can't. Normally, if we were on paper, here's how I'd want you to do it if we were on paper. CD, line segment CD is parallel to line segment BE. This is how I'd want you to do it if we were doing this on paper. But because we're doing this on Google Form, you'll actually have to write out line segment CD is parallel to, and I could say segment BE. All right? Because we're on Google Form, you'll actually have to write the sentence out, which is a lot more tedious than actually the geometric notation. But also the geometric notation takes a little while to get used to. And I want you to get used to this. I want you to get used to seeing this and be able to write this. But this is just the limitation of what we've got here. If any of you need to be able to do your responses on video as an alternate way, if typing these in is a struggle for you, let me know. Email me. You'll have to, or let me know when I call you, because I can create like a flip grid, and then you can do your responses to these, via flip grid, and you'll just be like, all right, I'm looking at, Unit 3, Lesson 1, and identify a pair of skew segments, and then you'll say, okay, skew segments. You'll tell me which ones are skew, right? You'll say, let's see, segment CD is skew to segment BF, right? How do I know that? Because they're not on the same plane and they're never going to touch, okay? I just gave another one away. Look at that. So I want you to give these a shot. I think we've done enough front loading that you can do that. Let's talk about the transversals. So again, a transversal, just to review, is a line that intersects two coplanar lines at two different points. So this here would be a transversal. but these are not looking like parallel lines to me right now. However, which means 1 and 5 are going to be corresponding angles, even if these two things aren't parallel. But now I don't know that these are not going to be. If these two things here, if R and S are not parallel, then I don't know that 1 and 5 are going to be the same measure. All right. So these 1 and 5 are corresponding. 3 and 4 are alternate interior. There's 3. 3 and 6. Angle 3, angle 6 are alternate interior angles. Yes, they are. They're on alternate sides of the transversal. They are interior to the two lines they are cutting. Alternate exterior, angle 1 and angle 8 are exterior, right? They're on the outside. They're alternate. They're on alternate sides of the transversal. And then same side interior, angle 3 and angle 5 are on the same side of the transversal, and they are interior to the transversal. So we're just reviewing some of those words. I need your brain to, when you hear corresponding angles, be imagining, visualizing a certain look, and then that you can then identify. Because without that, you're going to struggle on these regions if you ever take the geometry regions. And I just want this to be more of I want some automaticity, automatic recognition to some of these vocabulary terms. All right, so here we go. So in a minute, I'm gonna start asking you to give examples of an angle pair. So I might give you, say, find an example of corresponding angles, right? And I'll need you to write something like angle 4 and angle 8, right? So looking for corresponding angles. Angle 4 corresponds to angle 8 because they're both on the lower left-hand, quadrant of where the transversal cuts the two lines that are being cut. Definitely not parallel lines. Alternate exterior angles, angle 2 and angle 8. Angle 2, angle 8 are exterior. They're alternate. These are alternate exterior angles. Alternate interior angles. Alternate interior angles. Angle 4 and 6. Angle 4 and 6 are definitely alternate. They're on opposite sides of the transversal. They are interior to the two lines. They are alternate interior angles. And then same side interior angles. Okay, same side means they need to be on one side. 4 and 5 on the same side, and they are interior to the two lines. So with that, I want you to give these a shot. Give me an example. I'll do one. So you know what I'm expecting. All right, give an example of an angle pair of corresponding angles. So corresponding, remember what corresponding means? Do you? Corresponding means they're in like the same position. So for instance, I notice that 2 and 4 are like in this upper right-hand corner, right? They're corresponding. They're in the same upper right-hand corner. So I'm going to write angle 2 and angle 4. All right? That's what I'd write in there. I see that they're corresponding. And that's what I want you to do for these next ones. Give that a shot. Give these a shot. All right, example 3 here. Identify angle pairs and transversals. So identify the transversal and classify each angle pair. So if I give you angle 1 and angle 5, there's angle 1, there's angle 5. So let me see. What am I noticing? I'm noticing that if angle 1 and angle 5, what's the relationship? I'm noticing they are alternate interior angles, right? You see how angle 1 and angle 5 are on opposite sides of this line. They're on alternate sides of the line, and they are interior to angle L and angle M here. Can you see that? All right. Let's see. If I give you angle 6 and angle 3 and angle 6, right? There's angle 3. There's angle 6. I notice that they're on the same side of the line. I notice that they're both in the lower left-hand kind of corner of where these things touch. These are going to be corresponding angles because they're in the same position. They correspond to each other. And if the transversal is line L here, and I give you angle 1 and angle 4, there's angle 1, there's angle 4. I'm noticing they're on opposite sides of the transversal. I'm noticing that they're exterior, right? They're exterior, and that they're alternate. So they're on opposite sides of the transversal, they're on alternate sides, and they're exterior to the intersection, therefore alternate exterior angles. Let me do one and let you run with these. Give an example of a pair of alternate interior angles. Alternate interior. So alternate means they have to be on opposite sides. So immediately I'm thinking 2 and 4 or 1 and 3. So either one of these works. I'm going to use 1 and 3. Notice how 1 and 3 are on opposite sides. They're alternate and they're interior. They're inside the two parallel lines. So I'm going to say angle 1 and angle 3. Yeah, that was terrible 3. That's a really ugly looking 3. Okay, that's what I'm looking for here. All right, give these next ones a shot. You're pausing the video. You're working on these. You're doing great work. Wax on, wax off, Danielson. All right. Identify one pair of parallel segments. Identify one pair of parallel segments. All right. I'm going to let you do that. I think you can just look at the notation there. I don't want to give that one away. Remember to say say segment, letter and then letter, right? Identify a pair of skew lines. I think I will do this one, mostly because my clock's about to chime 12 times because it's noon, which means I need to get some lunch. All right. Identify one pair of skew segments. So I need two lines that we're never going to touch because they're not on the same line. So let me say I'm going to go with segment AB here, and then segment CF, right? They're not even on the same plane, therefore they're never going to touch. All right, so they're skew segments. So I might say something like segment AB and segment CF. Now notice I didn't actually have to write a little line above it because I already wrote segment. This is just the natural geometry notation that you would normally use if we were doing these on paper. All right, identify one pair of perpendicular segments. So you're looking for that 90-degree angle. I'm going to let you do that. Look for the notation. Look for the notation. I see a notation on this diagram which indicates a 90-degree angle somewhere. Okay, you can do the rest. Remember, you can always pause me whenever you need to, right? Need me to shut up? You can rewind, fast forward, skip parts. If these are easy, you can skip this part. One pair of parallel planes. One pair of parallel planes. All right, and then so plane, you just write, plane. Maybe you write plane ABC is parallel to another plane, right? That would be easy. I see the notation of parallel between here and here. All right, give an example of an angle pair of same side interior. Same side interior angles. All right. Maybe, do you need a hint? Do you need a hint? Pause me. Pause me if you don't need a hint and write it down. Okay, you unpause me. And, well, these two are same size, same side interior. And then these two are also same side interior. You could have used either of those and you'd be fine. All right. Give an angle pair of alternate exterior angles. Alternate exterior. I think you can handle these. I think we've gone over it enough. I'll let you give these a shot. All right, so you're probably pausing and you're writing those out. You're unpausing me now. You're identifying one pair of perpendicular segments. Identifying one pair of perpendicular segments. So I'm looking for two segments which are perpendicular that are intersecting at a 90-degree angle. So I'm looking at my diagram and I'm noticing there's some notation here which indicates perpendicular, which indicates 90 degrees. And I'll just do this one. What the heck? I don't want to give them all away, but so I noticed this notation here that says 90 degrees. So I'll say, you know what? I'll even write the seg BH and segment EH. All right. There you go. There's a freebie. I'm going to let you handle these. I'm going to let you handle these. I'm training your brain to think in 3 dimensions and look at figures and interpret figures. All right. So a lot of this is I'm just trying to train your brain to immediately recognize through practice, through repetition. If this feels repetitive, yeah, I know it is. I know. Sometimes that's how we learn. I'm going to need to fix this. This is an error. I'll create that a short answer text there. But I'm just trying to train your brain to have some immediate recognition of some of these vocab terms with diagrams as you see them. Identify a transversal and then classify the angle pair. So if I say angle 2 and angle 3, oh, you could actually copy this little angle symbol and then you not have to write out angle every time if you wanted to. All right, so identify the transversal and classify this angle pair, angle 2 and 3. So there's angle 2, there's angle 3, and I want you to see that what's the relationship between angle 2 and 3? I want you to ask yourself that question. I want you to visualize, look at the diagram and visualize and notice they're both in the upper left-hand corner of where these two things cross. They're both in the upper left-hand corner. What vocab is it where they're in the same position? They're in like the same quadrant, in the same position. That's corresponding angle. So that's what I'd have you write. Corresponding angle. Or actually, you might have to write it out unless you copy and paste the little angle symbol there. Corresponding angles, right? They're corresponding because they're in the same position. All right, identify the transversal and classify this angle pair. 4 and 5. Oh, 4 and 5. Well, they're interior to the 2 parallel lines, and they're on opposite sides of the transversal. I'll leave you to it with that hint right there. Okay. Angle 2 and 4. Angle 2 and 4. Angle 2 and 4. Well, this is interesting. I'm glad I was looking at this because the transversal of 2 and 4 is actually line L. The transversal is line L, and they would be alternate exterior angles. This one was tricky. If you found this one hard, if you tried this on your own and found this one hard, this one is hard. I was being sneaky with this one here. So the transversal is L, and that's the line that these two and 4 are like next to, and that these two are the lines that it's cutting, Q and P, and 2 and 4 are on opposite sides of this transversal, and they are exterior. So exterior. Oh, I need alternate exterior, and the transversal is L. All right, and I think I neglected to also identify the transversal on these other ones. I probably won't hold you to that because it did ask for identify the transversal. So like even here, when I said 4 and 5 are on opposite sides of the transversal and they're interior to the parallel lines, I would have to identify that Q was the transversal for this one and for that other one as well. All right. I kind of skipped that spot there. I'll let you do this one on your own. And I always try to add a little bit of an application to all of these. So, Mr. Salt, where do you actually use this in real life? You know, sometimes I struggle where you use some of this stuff in real life. But here's an example. In sports, a football player runs across the 30-yard line at an angle. He continues in a straight line. He continues in a straight line and crosses the goal line at the same angle. Describe the 2 parallel lines and the transversal in the diagram. So what I want you to notice, I have too many announcements going on in my house at this time. All right, that's a line which is parallel to this line. Oopsie daisy, I goofed that up. These 2 lines are parallel, and they are cut by a transversal. The 30-yard line and the goal line are parallel to each other, and they are cut by a transversal, which is the angle of the player running. And to describe the two parallel lines and the transversal in the diagram. So if I was to, you know what, I'm going to, I'm actually going to type this out. It's way easier for me to type this than to actually write it out. If it will let me. No, it won't let me. Okay. Well, gosh, that's disappointing. Okay. I guess I will have to write it out. Next time I'll know better. I'll have to do. I'm in the editing part of the form, so it won't let me write on it. Unlike you, who can just type in that little section there. Okay. So I'm describing two parallel lines. So I'm going to describe the 30-yard line is parallel to the goal line. It's really hard for me to print because I want to write fast, and this board doesn't let me write fast. It starts to look crazy when I start writing fast. All right, parallel line is parallel to the goal line, and the angle the player runs is the transversal. Okay. The 30-yard line and the goal line are parallel lines, and this line here is the transversal. That's what you'd type. That's the kind of the expectation I would have for what you would respond in for that answer there. Aviation is another application of this, right? Describe the types of lines formed by two planes when flight 14489 is flying from San Francisco to Atlanta. There's San Francisco, California. There's Atlanta, Georgia. It's flying at 22,000 feet. And flight 2390 is flying from Dallas to Chicago at 28,000 feet. Keep in mind, they're not on the same plane. So what are lines that don't touch, that are not on the same plane? All right. And then these are the checks for understanding. And I do not help you with checks for understanding because this is the key. This is the part where I really want to know if you get this, if you understand. So you'll have to do these on your own. All right. You can do it. I think we've hit these ad nauseum. There's even multiple choice in here. All right. So the evidence, if you were successful with this lesson, you should at this point be able to identify parallel, perpendicular, and skew lines. You should be able to identify lines formed by two lines and a transversal. You tell me, were you successful at meeting the expectations of the learning target? Did you do great? Did you do good? Did you do okay? You need to improve? You get points. No wrong answer here. You get points for no matter. It's just I need to know, where you're actually at. What's your own assessment of where you're at in terms of your performance? I also want to know, what was your effort like, right? How well did you contribute to your own learning? Normally, this question we do in class, you get no matter what you click, you get full credit for this. I want you to assess how well you are contributing to your learning, right? I want you to just reflect, like, am I really trying my best? Okay. Assess the effort you put in today. So this is the effort question. You tell me how much effort you're putting in. And again, there's no wrong answer here. You get credit no matter what you choose. Even if you said I did not put in enough effort, you still get credit for this question because I really just want you to think whether you think you're putting in enough effort. What's one thing you learned today? What's the most interesting thing we did or thought about today? Yeah, probably you're going to have to talk about the airplanes or the football because I doubt most of you find parallel perpendicular lines enthralling. Maybe you liked my video, my green screen, all right? I don't know. Any feedback, questions, tell me how awesome I'm doing. Give me some constructive feedback on how I need to improve. Looks like I failed to give you an extension today, which is a little extra credit thing in there, but there's plenty of extra credit for you to do in the Google Classroom right now. So maybe there'll be an extra credit on your sheet when I fix this. Maybe not. And I think that means you're done. Great. We're done. Whew. Oh, wow. Okay. We're back. Okay. I hope you're all right. I hope I hope you're safe. I hope you're healthy. I hope you and your family are doing all right. Um, and I recognize that doing these online, it's going to be a struggle. It's going to be a struggle. I've got to put in extra effort just to do the video production for all these. I hope you're getting something out of it. I really just don't want you to lose the time, which is precious time for you to get an education. You deserve an education, and I'm trying to provide you something worthwhile and something that will help you. If you're a graduating senior and you don't plan to become an engineer and you don't plan to design houses or go into construction, then some of this geometry stuff may not apply too much to your life, and I'm sorry for that. If you want to go to college, then some of this stuff, even if you don't use math, the thinking skills involved of applying vocab terms, identifying things in figures, are going to come in handy in places that aren't necessarily considered math oriented. So remember, even if you're like, well, I'll never use this in real life, just the practice of thinking hard. The fact that you're struggling with this means your brain is struggling with this, which means we're activating new neurons, we're building new pathways, we're getting your brain swole, okay? And that's what it's all about. We're just trying to, to help you develop as a person. And I'm hopefully going to be producing these in order to try to contribute to help you develop as a person, further your education, okay? That's what the name of the game, all right? Getting better, improving all the time. Be a lifelong learner, and catch you on the flip side.